Foundations of Amateur Radio. The other day I saw a post by fellow amateur Gary November 8 Delta Mike Tango, who mentioned an RF circulator and a PlutoSDR in the same sentence. Amplified by a response from a fellow Aussie Electronics Engineer, ozeng, who helpfully added a link to a Wikipedia article about circulators, it finally twigged that I had such a gadget in my possession, and for the first time I realized how I might use it. Now, before I continue, I'll preface this with a disclaimer. This is a hand-wavy description of what this very interesting device does. Ozeng calls it absolute witchcraft, and that's an apt description if ever I've heard one. Imagine for a moment a radio with separate transmitter and receiver connectors, attached to the same antenna using a T-piece. As in, there's a run of coax coming from each connector joined together with a T-piece which in turn is connected to an antenna. The aim of this, don't do this at home contraption, is to avoid the need for two antennas. But, and it's a big one, doing this will very likely destroy your receiver the moment you transmit for the first time, because likely half the transmission will go to the antenna, while the other half makes its way to the receiver, which is not going to be something you want to happen, unless you like the smell of magic smoke. You might think that adding an attenuator, something that reduces the power on the receive port, would help. Well, yes, it would, but as a side effect it would also reduce the signal coming from the antenna. At that point you'll decide you need a switch. Initially you might switch this manually, but that's a pain if you're wanting to transmit and receive continuously, and need to remember in which position the switch is in. The next step is to use an electronic switch, like a relay. It can trigger based on some signal from the radio when it's transmitting and turn off the receive path during a transmission. This raises an issue with delay. Do you trigger just before you hit the PTT, as in time travel, or do you delay the transmitter until after the relay has switched, which will cut off the beginning of your transmission? You'll likely have heard this kind of issue when listening to a station using an external amplifier. Their signal either jumps from low power to high power after they key up, or you miss the beginning of their call sign. Not to mention that if you get the delay wrong, you'll blow up the receiver. Fun for people watching, not so much for the equipment owner. Even if you get the timing right, you cannot transmit and receive at the same time. Of course, an obvious solution is to have two antennas, but soon you'll discover that when you're transmitting and receiving on the same frequency, even using two antennas, you'll have the exact same issues. It's why the local 10-metre repeater here in Perth, Victor Kilo 6 Romeo Hotel Foxtrot, has the transmitter in one location and a receiver 12 kilometres away, connected to each other via a 70-centimetre radio link. Other solutions in this space are cavity filters, duplexes and diplexes. These all require that the transmit and receive frequencies are different, and the equipment is generally tuned to a specific pair of frequencies. Physically, cavity filters can be massive, not to mention fragile. So, solving the issue of having a transmitter and receiver together on the same frequency is one that is challenging, to say the least. It's a common issue. Think about mobile phones, satellites, broadcast transmitters, and even your own amateur radio station. An RF circulator is a device that solves this in an extremely elegant way. For starters, it's a passive device, which means that you don't need to power it. There's no moving parts, no switches, no delays, no external controls. It's a box, generally with 3 sockets or ports, though versions exist with more. At a basic level, it works like this. A signal inserted into port 1 will only come out of port 2. Similarly, a signal into port 2 will only come out of port 3. And finally, a signal into port 3 will only come out of port 1. Think of it as a one-way roundabout. How is this useful, you might ask? I'll illustrate by plugging in 3 things. Connect port 1 to an antenna, port 2 to a receiver, and port 3 a transmitter. When you transmit into port 3, the signal only goes to the antenna, leaving the receiver safe and happy. Similarly, any antenna signal will only go to the receiver. So how does this work? Remember, hand wavy. Essentially, it's based on the idea that radio waves travelling in one direction combine and waves travelling in the opposite direction cancel. Different types of circulators achieve this in different ways, and come in different sizes as a result. The RF circulator I have is roughly 60 mm square, 30 mm thick, weighing in at most of half a kilogram, and as far as I know, intended for operation around 850 MHz. If I recall correctly, it came out of a CDMA mobile phone tower. The parameters that describe an RF circulator are the frequency range, the insertion loss, or how much signal gets lost getting from port 1 to port 2, the isolation, or how much signal leaks between port 1 and port 3, and a couple of others. Hopefully I'll be able to use a nano VNA or PlutoSDR to get a sense of what these values are and confirm the frequency range. Now, if that doesn't blow your mind, wait until I tell you about the 200-year history that accompanies it. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.